So with this data, one more thing that we could do is we could look at generating a histogram. And that's essentially a visual depiction of the distribution of the data. And depending on how you interpret the histogram, that might shape how you choose to report your descriptive statistics. So, it might mean that you stick with the mean and standard deviation. Maybe you choose to report the median instead, or maybe in some cases you even report the mode. It depends on a study by study basis. It depends on the type of variable that you're working with. And to a certain extent it depends on the distribution of the data. With this type of data that we have, this social attractiveness data, which is taken from a scale, so there's a whole bunch of items, we deal with the individual item responses and we come up with a total score. So this was participant one's scores across the different tweet conditions, and we have some averages based across the 132 participants. We've got the mean, we've got the standard deviation of that mean, and we've got some other indications of central tendency here. Now we might want to visualize this by drawing a histogram. And the way that we do that is we select the data, not the header, so just the 132 data rows. I'm just clicking and holding the left mouse button down, and then we go to the insert tab, or the insert tab on the ribbon, and we want this little blue set of bars which says Insert Statistics Chart. We click on the little drop down arrow and we choose a histogram. So this has essentially allowed us to visualize our data, and it's grouped into bins. So it's taken the raw observations and it's condensed them into what are known as bins. So essentially we have sort of 30 odd values that were between 5 and 8.9. We've got probably around about 24 between 8.9 and 12.8, and so on and so forth. So unsurprisingly, all of our measures of central tendency, or two of our measures of central tendency, the mean and the median, were sort of 13, 14-ish, so it's not really surprising that this is the bin with the highest number of observations. Now, if we play around with the bin sizes, or the numbers of bins, we might actually change the shape of this distribution. So whatever approach we decide to take to visualizing this first set of data, that should be the one that we use all the way through, regardless of whether we're just talking about the other 6 parts here, or whether we're talking about when we look at physical attractiveness, task attractiveness, victim blame, perceived severity. So the first thing I want to do is give this a title so that I can keep track of what I was doing. So this was a negative tweet with high abuse following after. So I just want to label that figure so that I can keep track of my work. Pretty happy with this y-axis here. I don't think we need to change anything there in terms of the settings. So let's double click the values on the horizontal x-axis. Now it's set up to do it automatically at the moment, but we might want to change that for some either theoretical or practical reason. So let's say we want to force it into a certain number of bins. Let's say we want to use 10 bins. So we click on the number of bins here, and let's change it to 10 and hit enter on the keyboard. And you see that changes the distribution of the data. Maybe we want to change it even further. Maybe we want to break it into 20 bins. And again, you see that it changes the distribution of the data even further. What happens if we make it into 30 bins and we smash it down even further? You see it just gets smaller and smaller and smaller on the horizontal axis. But whether we're actually doing anything meaningful or not, I don't know. So let's keep it at 5, and again you see it changes the nature of that distribution. So generally, by default, the automatic is probably going to be fine, but you could actually force it in a certain way. You can do it categorically, but because we haven't actually coded any categories, I don't think you would do that in this case. So here we'll just leave it at automatic. What we could do is we could actually copy this entire figure. So I've highlighted it, I'm going to copy it. We click somewhere else on the worksheet and we'll do paste. Well, we'll just leave it as a regular paste, Control V. And as you can see, it's drawn the exact same chart. It's highlighted this data, but what we can do here is just drag across and relabel the chart. So that now becomes negative tweet, low abuse. And it's drawn the bins automatically, but maybe we think, I don't really want different bins across these two charts. So let's go back here, reopen the axis, and we'll say, okay, I want to have 7 bins. And we'll set this one here as well, double clicking on the values, open up the axis. This time maybe we want 7 bins also. So it's always going to be ever so slightly different because you'll have different minimum and maximum values, but at least this way you can add a little bit more sort of consistency to how you draw your histograms. But as I said, it's kind of up to you as researchers to decide on that, and that might be driven by theoretical or practical considerations within the data. Different packages do it differently. Different packages give you different amounts of control over the data. So another way that we could have done it would have been to go back to these bins, open up the chart editor, and in terms of bin width, yeah, let's just say we only want a bin width of 3, and we hit enter. So again, it changes that distribution, and let's set this second chart as a bin width of 3 also. And again, it just ever so slightly changes it. And this is quite nice because this means that these two charts now have the same scales, and that so happened because we had a minimum value. Now, because we've got a minimum value of 5 in each, it's possible that we could set up these similar types of bin widths. So let's do it on the next one. So we'll copy and paste the whole chart. I'm just using Control C to copy that chart. I'll paste it. We drag those bars across, and this time we need to relabel it as a neutral tweet with high abuse. Neutral tweet, high abuse. And here we can open up the chart editor. We can select our bin width and set it as 3, and again that just makes it consistent with the other charts, certainly in terms of the lower ends of the spectrum. But because we've got a higher maximum value, this histogram extends further to the right. And I think it's quite clear just from looking at those 3 that there's a bit of a difference in how the scores are distributed. So when the initial tweet was negative and someone received high abuse, they're not actually rated as particularly socially attractive. When it's a negative tweet and they've not received much abuse, yeah, they're maybe coming out a wee bit more socially attractive. And then if they've posted something neutral, we don't get many of these low ratings, but we're getting a bit more towards the middle and higher ends of the scales. So it's interesting to see how the ratings of the participants, the ratings of the victims, if you want to think that way, are starting to change. And let's just do one more. We'll copy it again, but this time instead of looking at neutral tweets and high abuse, we'll look at neutral tweets and low abuse. And let's just relabel the figure so that we can keep track of our work and not get confused. And again, we'll change these bins just by double clicking on the values into our axis options. Bin width, we can set that at 3. And again, we can see here, neutral tweet and low abuse, we're getting even fewer of those really low ratings of social attractiveness, and it's starting again to creep up into the kind of higher ratings. So it's quite interesting to look at our data that way. It gives us a hint at what might be happening, and it also shows the kind of normality or non-normality of the data distribution.